Hello everyone, this is Chandrasekhar here. Welcome to my Kubernetes Zero to Hero session. This is fourth episode of Kubernetes Zero to Hero session. In fourth episode, we'll talk about why pods alone are not enough, and we will try to understand one higher objects in Kubernetes, which is ReplicaSet. We will also try to understand how we can ensure desired state is same as actual state by using replica set, and we will try to understand replica set architecture as well. We will create replica set, we will scale replicas by using replica set, we will see self-healing feature of replica set, and we will see the importance of labels and selectors. Also, we will take a glimpse of more higher object which Kubernetes offers, which is deployments at the end of this episode. So let's first start what we learned in episode 3. In episode 3, we learned about pods. We have created pods, we inspected pods, and we deleted pods. Let's revisit something by executing some command. So the command which we executed to create pod in episode 3 is kubectl run nginx pod hyphen hyphen image equals to nginx. And we understood execution of this pod by executing another command kubectl get pods, and as we executed we found that the pod which is with the name this is in ready state. In few minutes it will be in ready state. You will see 1 out of 1 is in ready state. Status will be ready, and if there is any restart count, it will show that it will show the time before which it has been created. So now this we saw in our last session. Let's execute the command once again, and now you see it shows as running. Now let's try to delete this pod. kubectl delete pod and give the name of the pod, which is nginx pod. As I've executed this command, it says that the pod from default namespace has been deleted. And if I execute kubectl get pod now, it says me that the pod has been deleted. So what basically happened? The pod disappeared. Now imagine a situation. Your company's website is running in a pod, and nowadays almost every company's website is running in a pod only. For some reason, if pod crashes, because pods are of very short duration, they are ephemeral in nature, or someone accidentally deletes the pod, will the application which is hosted on those pods, will your company's website which is hosted on those pods remain? No, they won't remain. They will disappear. And that is a huge problem. Today we are going to solve that problem. Today we are going to understand how to solve this problem using a higher object called a replica set. Imagine a real world scenario. You are working as a DevOps engineer in a company wherein your team is having 4 members. You are having a 4 team members in a DevOps team, and for some reason one team member resigned. But your manager wanted 4 DevOps engineers to work properly to run the business. So if one DevOps engineer resigned for some reason, the manager immediately will hire another DevOps engineer, will immediately hire another person. Why? Because the business demands it. Replica set works exactly the same way. Replica set ensures that total number of pod count remains same as it is desired. It should not reduce. It should not fall below the standards. So now a question comes. Can a pod fail? Yes, a pod can fail. Can a pod be deleted? You saw that few minutes back. Yes, the pod can be deleted. Can a node fail? We'll talk about node failure and how to overcome node failure also in our upcoming session. But yes, even nodes can fail. Pods are temporary. Production application needs availability. Your company website needs availability. If you are unable to maintain high availability for your company's website, then there will be huge loss to business. Business applications cannot disappear because one pod crashed because someone accidentally deleted the pod. This is why Kubernetes offers a very important and high level object to which we call as a replica set. A very simple definition of replica set is replica set is a object which ensures that a specified number of pod are always running. So what a replica set does, a replica set is going to ensure you replica set replica set what this will ensure that desired is equals to actuals. It's not as in the desired is 3 and actual is 2. No, it is the responsibility of replica set to ensure that this is going to work. So you can consider replica set as a pod manager, like the way we a few minutes back we have saw we just learned from example of DevOps engineering manager. Similar to that, consider replica set is a pod manager. So with replica set, what happens? With replica set, consider that the desired pod is 3, desired pod is equals to 3. Pod 1, pod 1, pod 2, and pod 3. These are the 3 desired pods. Now, if one pod for some reason disappears, either it crashes or it is accidentally deleted, then the missing pod will be noticed by replica set. Replica set is going to notice that and it will bring all the 3 pod. It will ensure that the pod count remains 3 every time, whatever you are defining there in your desired as a desired value. It will always ensure that the count remains same. This is the main job of a replica set. Now, how will we create a replica set? In order to create a replica set, we must have a manifest file. So I have just pushed the manifest file in Kubernetes commands folder, and here I have created a folder which is with the name manifests, and this is the file rs.yaml is the file which contains all necessary script to create a replica set for you. I do have same file present here as well. So let's try to understand this file. So in this file, you can see the kind is a replica set. So Kubernetes basically offers object of multiple kinds, multiple types. This kind tells that Kubernetes, I want to create a replica set specifically. This is the main use of this kind. Another important thing is under metadata, we provide name. This name says that the name of the replica set is going to be nginx-rs. Another important thing is replicas. This says the desired value of the pod which I want. This talks about the desired number of pods, and now replica set will always try to maintain desired number of pod which we put beside replicas. In our case, it will always try to maintain 3 pods. Another important component is selector, this specific part. This selector tells replica set that this replica set will manage only those pod which is having label as app nginx. This is the label. This replica set which is with the name nginx rs is going to manage only, there can be huge number of pods, but this replica set will be managing only those pod which is having label as app equals to nginx. Other pod it is not going to worry. Another important thing is template. This template will be used before creating pods. So every pod which is created by this replica set will follow this template only. So this will be the template which will be passed to each of the pod which will be created under this replica set. Now this is now replica set which is managing individual pod. So previously what happened? Previously, when we created pod, consider this is a pod. So this pod was created as a standalone pod. This was a pod which was created as a standalone pod. We deleted it and it is gone. So now what we are going to do, we are creating one higher object to which we call as a replica set. So this is a replica set. And now within this replica set, we are going to manage more number of pods under this replica set only. So now this will be pod 1, this will be pod 2. For some reason, if any of the pod goes down, then it is the responsibility of a replica set to ensure that the pod count remains same as desired, as you kept under replicas section, as you put at this specific point, replica set will maintain those number of pods. So now let's run this and let's create it. In order to create, first I have to come to this specific path. Now let's cd to that specific path, and here I'm going to execute a command kubectl apply -f rs.yaml. So if you have a manifest file, you have to execute kubectl apply -f, and after that you pass the name of the file where your object related definition is present. Now, in my case, replica set definition is present in a file which is rs.yaml. Hence, I'm passing that file here. As I hit enter, it says that replica set this is created. So it has created a replica set. Now I'll go back to I can execute command here also in VS Code also. But just for more clarity, I'm coming here to my terminal and I execute the command kubectl get rs. What it says, replica set which is with the name nginx rs, same name which I gave in my manifest file is created. It is having desired number of pod as 3, current or actual number of pod is 3, ready is 3. Everything it says. Now these are the pod which is created. Now let's see the pod which is created under this specific replica set. So I'll say kubectl get pods, and now you see it says that these are the 3 pods which are created. Did we create these pods manually? No. We did not create any of these pods manually. Who created it then? It is created by a replica set. Now if you see the name of the pod is prefixed by name of the replica set, and after that there is 5-digit alphanumeric value. So always any pod which is created under a replica set will be prefixed. The name of the pod will be prefixed by name of the replica set. Now it says that 3 pods are running. Now, what is the best moment? Like the way we learned earlier, that it is the responsibility of replica set to ensure that 3 pods, all the replica desired count remains same. So let's see the wow moment here. In order to understand, let's execute the command kubectl delete pod like the way we executed earlier also. Kubectl delete pod, and let's give the name of the pod. Now this is the command to delete the pod, and I'm deleting the pod. It says that it is deleted. So ideally there should be 3 pod. But what I see now, even though I try to delete the pod, another pod is created, and you see the age of this pod. The age of this pod is just 4 seconds, which shows that it is created very recently. Other 2 pods were created 2 minutes ago, but this pod is created just 4 seconds ago, the time when I try to delete the pod. This is the wow moment of a replica set. Replica set ensures that always desired number of pod is available. Imagine a bank. What is the security policy of the bank? The security policy of the bank says that, and security policy says that always keep 4 security guards, which is very much essential to maintain security of the bank. The current state is all the 4 guards are present, but for some reason, for personal commitment, for professional commitment, 2 guards had to leave the bank. The current state is only 2 pods are present, but the policy says always 4 guards must be present. What happens immediately following the policy? 2 new guard arrives. And now, instead of, even though 2 guard left, still the bank is maintaining the count of 4 guards. Similarly here replica set acts and works on the same principle. It ensures that even though any of the pod is deleted or is destroyed accidentally or knowingly, it is going to create it again back for you. So now, how does a replica set? The important question comes, and this is one of the very important interview question also. How a replica set knows which pod belongs to this specific replica set? And that is where I was talking about this label. This label, this label is the one which replica set looks after. This rebel app equals to nginx is the one which replica set looks after and says, okay, fine, any of the pod which belongs to this label is under replica set nginx-rs. So now, in order to execute, in order to understand that, what I'll do is I'll show you label also. So kubectl get pods hyphen hyphen show hyphen labels. If I execute this, then what it says, you see, all the three pod do have labels app equals to nginx, and this is what even replica set monitors. So labels are like tags. For example, if I have to give you a real world example, in an organization, there are multiple departments. HR is a department, IT, finance is a department. These are the tags for those departments. For example, if you have to visit, you will just say, okay, fine, I have to go to HR department. So HR is a tag which is associated. Similarly, for every replica set, for every pod, there is a tag associated in real time, and on the basis of which replica set decides, okay, fine, this is the one which I have to manage. Now, let's talk about the scaling of a replica set, how to scale it. Tomorrow, there could be a scenario wherein I have to increase the count from 3 to 5. So what I'll do, I'll come back here and increase the count from 3 to 5 and reapply it and reapply the file. You see what happens? I have applied. So previously when I executed the applied command, it says that replica is created. But now when I applied it, it says the replica set is configured. So it's not recreating it, it has reconfigured it. And if I execute get pods now, you see two pods, which is with the age of 17 seconds, are created recently. So you have increased the count. So you have scaled up. In order to scale down, again, you just reduce it from 5 to maybe 2. And again, you execute the command. Again, it will say configured, not created. Now, if I come back here again and execute get pods, you see the pod count reduced from 5 to 2. So it is the replica set which is capable of managing the pod count from 3 to 5 and 5 to 2, increasing, reducing. Everything can be managed by a replica set. So just to summarize, some very important section which we saw in this specific manifest file is replica set name, replicas, selectors. This selectors decide labels. This label is something which replica set look after and decides, okay, fine, which of these will be managed under this replica set. So replica set looks amazing, isn't it? Replica set is something which is capable of upgrading things, downgrading things, scaling up, scaling down. This is what replica set does. Now, how will you clean up? In case if you have to delete everything, you just have to delete a replica set, execute the command kubectl delete rs and give the name of the replica set. Now, since we are executing all the command in our terminal, to avoid any confusion, let's go into our terminal only. So kubectl delete rs and give the name of your replica set, which is nginx-rs. This is the name of your replica set, right? So give the name of your replica set, and replica set deleted from namespace. And if I check, rs is deleted. If I check for the pod, everything is deleted. So all the pod which it has created, everything is gone. So pod, remember this thing, pod can fail, pod can be deleted, pod has no self-healing mechanism. How replica set provides benefit? It maintains desired number of pod. It provides self-healing. It supports scaling also. It uses labels and selectors as well. So what we have learned in this session? In this session, we have learned about the desired state, actual state, self-healing, labels, selectors, and Kubernetes loop of reconciliation. This is what I wanted to cover in episode 4. Hope you liked this episode. If you did not subscribe my channel, please subscribe it so that you remain updated on all my upcoming videos. Share this video with others who all can get benefited because of these videos. Thank you again everyone for watching. In next session, I'll talk even more advanced topics in Kubernetes, which is deployments. In those we'll understand about rolling updates, rollbacks, zero downtime deployments, deployment histories, and many other things. See you in my next session.